All right, folks, apparently it's time to get started. And I'm feeling much better today. I'm not sure if you've been to the talk that we had yesterday. I had a really bad throat yesterday, so now I'm feeling almost back to normal. So thank you for coming over. My name is Jose Barreto. I'm a principal program manager with the file server and clustering team at Microsoft. This talk is about the Hyper-V over SMB scenario, which is basically virtualization with file storage, which is something that we introduced in Windows Server 2012. Now, in this talk, we're going to do a big overview, including all the things that we did in 2012, and we will also have highlights of what we changed in Windows Server 2012 R2. And you'll see that it's a consistent story. My demos are all going to be using the 2012 R2 preview, okay? We're also going to talk a little bit about performance. I'm going to have a performance demo as well. And we're going to talk about configurations and how can you put this together. And that's a question I get a lot. What are the pieces that we need? How do we create a balanced system? Okay? Let's get started. So we'll do an overview, we'll do basic configuration, performance, samples. So what are we talking about here? We have, up to this point, many different ways to do shared storage for virtualization. Many different ways that you could build your private cloud, okay? But before 2012, you really had only two options for storage: Fiber Channel or iSCSI. Now, we're on a quest to make these private cloud solutions more affordable, meaning lowering the cost of deploying this solution. And interestingly enough, storage is a big piece of it. And storage has traditionally been very expensive. We are working to make those solutions for storage more affordable, reducing both the cost to acquire those and the cost to use them, to operate them. So with that, we get this vision. So the vision for storage, if you come to me today and say, Jose, I got nothing. I'm just starting to think about a private cloud, and I'm starting greenfield. I can go in whichever direction I want to do. I would highly recommend that you would use a solution where you have a compute layer with Hyper-V nodes and a storage layer with a scale-out file server, okay? And behind that scale-out file server, you have JBODs, just a bunch of disks. So raw disks exposed directly to the file servers, okay? With that, you get industry standard servers, industry standard networking, industry standard storage, and the lowest possible cost for a solution that performs well and is highly available, okay? It is also something that's very easy to put together, and I hope you will see all the effort that we put into making this a very simple solution. So this is my one slide that tells the whole story about Hyper-V over SMB. So you have your Hyper-V cluster on the top, you have your file server, you have your shared storage. Before 2012, file storage, SMB file storage, was something that we used for Word documents, for PowerPoints, for these kinds of traditional, what we call information worker documents. In 2012, we put a lot of effort to make that file solution a first-class solution for application server storage, for Hyper-V, for SQL Server, okay? Now, in order to get there, in order to be put side by side with a storage array and feel like we are at the same level, we had to address a few things that were issues before 2012, before SMB 3.0, okay? Those issues included, for instance, continuous availability. So when you have a SAN, you have two controllers. You need to update the firmware on the controller. How do you do it? You update one controller, then you update the other, and there is no downtime. So on the file server side, we have implemented this thing that we call SMB transparent failover, which gives us continuous availability. What does that mean? That means that if I have a 2-node file server cluster, and I need, for instance, to add memory to one node, or I need to replace a driver, or I need to apply a patch, or whatever I need to do maintenance on, I just simply can take that server offline, and whatever workload was hitting that node of the cluster gets transparently moved to the other side. Scale out. I have multiple nodes. I want to make sure that all those nodes are active at the same time so that the load is properly shared. We delivered that in 2012, and we made it better in 2012 R2, and I'll cover some of that. SMB multi-channel. So we were just talking down here about comparing iSCSI to SMB and some of the fun things around that. But one of the things that we made a point of doing was in configurations where you have multiple NICs or multiple paths, most solutions will require you to configure those pieces separately. And the notion is, with SMB, if there are multiple paths, SMB will not only use them, but they will discover, the two sides will discover the multiple paths automatically. So if you have two 10 gigs, you get 20 gigs of throughput. If you have 8 1 gig NICs, you get 8 gigs of throughput. And you don't have to configure anything specific other than make the network be there. And there are other things as well, for instance, low latency with SMB Direct, encryption, backup, management. Let me go over a few of those things specifically. First, transparent failover. If you ask me what is the single most important thing in SMB 3.0 that actually make this a solution that is viable for Hyper-V and for SQL Server, it would be this. It would be transparent failover. What does that mean? So again, with a little bit more detail. Let's say you have a 2-node file server cluster, and you have 100 Hyper-V hosts storing VMs on those 2 nodes. Okay? You have 1,000 VMs in flight. What you can do is you can actually pull the power plug on one of the 2 nodes, which is handling a couple hundred VMs or something. And the Hyper-V host will automatically get redirected to the surviving nodes. From Hyper-V's perspective, it is a non-event. It is an I/O that takes a little bit too long, but there is no impact to your workload. That is the promise of SMB transparent failover. What you need to do is you need to put 2 servers in a cluster, and you need to configure what we call a file server cluster, meaning that you have a name that refers to both nodes as a set. And then we'll do it automatically. Okay? And we will handle these transitions, and your workload, your SQL workload, your Hyper-V workload, which is the scenario here, will just survive any of these situations. Okay? You do have to have your shares enabled for continuous availability, but that's the default if you have a cluster. Okay? Now, on top of that, we do scale out. So before 2012, if you have a file server cluster, you would have a name that will be up, that would be up in one of the nodes. Let's say you have a 2-node file server cluster before 2012. One of the 2 nodes would be playing the role of the file server. The other node would be waiting. And only if that first node failed would the second node then do something. With 2012, with the introduction of what we call SMB scale-out, we now have the notion of multiple nodes in a cluster that all are active, meaning that if you have a single file share on that cluster, it will show up in every node. And as I was describing before, if you have 100 Hyper-V hosts hitting that cluster, they will hit different nodes of the cluster. They will spread out using round-robin meaning the first one hits the first node, second one the second node, so on and so forth. So if you had, for instance, 4 nodes in the file server cluster and, let's say, 100 Hyper-V hosts, then you have 25 Hyper-V hosts in average across the cluster, right? That is enabled by a technology in failover clustering called CSVs, Cluster Shared Volumes. Not sure if you heard about it. That was introduced a little earlier, but for the first time in 2012, we were able to create a file share on a cluster shared volume. Cluster shared volume is essentially this notion that you have all nodes of the cluster being able to access the same, essentially the same volumes, the same folders, right? So you can actually have that enabling through the file server to have that capability remotely. So you can actually hit any node of the cluster and they will all have the ability to access that data. That is key for us because it helps with our ability to scale. So we support this configuration with up to 8 nodes in the file server cluster. With each node, for instance, having a couple of 10 gig NICs, you could imagine that you could have an 8-node cluster with 20 gigs of throughput in each one, so we can get a really large file server cluster. It also helps a lot when you need to take a node down for maintenance, because if you only have 2 nodes in your cluster and you take one down for maintenance, then you're down to just one. At that point, you no longer are fault tolerant. But if you have, for instance, a 4-node cluster, you can safely take one node out for maintenance, and you still have 3 surviving nodes, and you can still move forward and be relaxed, saying that, okay, if something else goes wrong, I still have 2 nodes, I can still keep going, okay? In this scenario, we made a key change in R2. So whenever you see that little star over there, that means I'm talking about something that's new in R2. When there isn't a star over there, I was talking about something that is for both 2012 and 2012 R2. So one of the things that we did is we fundamentally changed how a client chooses the node that's going to talk to. So in 2012, a client would pick one node of the cluster, and one client would only choose one node of the file server cluster. So remember the scenario had 64 Hyper-V hosts and 4 file servers? Each one of the 64 would pick one and only one of the 4 nodes and do all work with that node. And while that was okay, some people were trying to make sure that things get spread across nicely. And if you have, for instance, one node that's doing a lot more work than others, there would be no way to kind of split the work from that node. And we introduced that in 2012 R2. So now in 2012 R2, instead of choosing one node per cluster, we actually will do this per share. So if you have multiple shares, and you typically do, your client could be accessing one node for a certain share, another node for a certain share, another node for a certain share. So you could spread that further. So a single client now in 2012 R2 can spread the load across multiple nodes of the scale out, making us scale out even better. Not only that, but we also delivered on the ability to, on the CSV side, spread our volumes across the multiple nodes. And if you understand how storage spaces works, the coordination node for a given storage space will actually have better access to that data. So we are now aware of that. So if you have different nodes, each owning different cluster shared volumes, we will spread the cluster shared volumes, which will then spread the shares. And now we can actually make that balancing work really nicely in a private cloud scenario. Okay? So those are all new capabilities in R2. And this essentially gives you this automatic rebalancing. So if you have 2 nodes in a cluster and you add a 3rd node, the load gets extended to that node as well, right? If you have 4 nodes in a cluster and you take one out, those volumes get absorbed by the 3 surviving nodes, and the clients will spread accordingly. So we work better when you add, remove nodes, and you can balance better in 2012 R2. Multi-channel. Great feature. Very simple to explain. If you have multiple NICs, we'll use multiple NICs. We'll automatically discover that you have multiple NICs, and we'll automatically engage all NICs for the operations. So I've seen folks do this with 2 10 gigs, multiple 1 gigs, multiple 56 gig NICs, which is a demo that I'm going to do. Okay? So we can actually leverage those multiple paths. But it's not only about that. It is about, I have 2 10 gig NICs, and for some reason, 1 NIC goes away. Or someone pulls out a plug that they shouldn't have. What happens to your workload? We just continue to work with the surviving NIC. So we did a demo when we first introduced this, which was quite fantastic. We start with 1 gig NICs, and then while the workload is running, I plug a 10 gig NIC, and then the workload moves to the 10 gig NIC. And then we plug another 10 gig NIC, and then the workload starts using both 10 gig NICs. Then we plug a 56 gig NIC that's RDMA capable. Then the workload starts using that. And then we put 4 of those. All with the system running, we're just plugging cables in the back, right? And you can actually unplug cables as well, and it just adjusts automatically. And that sort of capability is key for fault tolerance in this environment. So it's not about tolerating the fault of an entire node, but also tolerating the fault of a NIC or a switch. So if you do this right, you actually get a really interesting capability with performance. So we have a number of tricks there to use multiple TCP connections to balance better. If you understand what receive side scaling is, if you have 1 NIC, we'll actually balance across the multiple cores of the machine. So a lot of attention put to the performance of those things, which honestly, when you compare us, for instance, with iSCSI, we can many times perform a lot better due to multi-channel alone. Now, if you're really concerned about performance, you should take a look at RDMA. Let me tell you a story. About 4 years ago, when we started planning this, we said, okay, we have to have something in the file server that works really well, and we want to be able to put this side by side of a SAN and have no shame of saying, you know, we can perform as well as that. But then we faced the trouble called fiber channel. Fiber channel is a very efficient way of transferring data. You know why? Because they have these things called HBAs, which are essentially dedicated cards that do nothing but take care of your data movements. And they're very efficient at that. And at first, when we started looking at this, people said, you know, we'll never be able to beat that with TCP/IP. Because TCP/IP, we actually always have to chunk the data into small pieces, right? And then transfer small pieces, and then the other side reassemble. While the fiber channel HBAs is transferring large amounts of data at very low latency. But while we were thinking about that, we looked at something called high-performance computing. So there were some folks out there, they had these NICs that could do these low-latency transfers, these high-performance data transfers with very low CPU utilization, and we looked into that. The problem is those require changes to your applications at a different programming model. But then some crazy guys in our team said, you know what? We can make that happen. We can put this inside SMB and make it completely transparent to whoever is above us. And that's exactly what they did. So, starting in Windows Server 2012, when you have a NIC that has this ability, which is called remote direct memory access, when we detect that both sides have it, we will actually start transferring data in a completely different way. So let's say, for instance, you have 1 megabyte of data that you want to transfer from point A to point B. In the old days, we'll take that 1 megabyte and we'll chunk and send piece by piece. Then on the other side, we'll reassemble, give it to the workload. In this new mode, what we say is, okay, so there's a memory here, 1 meg. I'm going to create a registration, take a token, send to the other side. Then the other side, the NIC, will directly remote into this box and transfer the entire data from one machine to the other. And the 2 NICs are doing the transfer. The main CPU is actually not involved. And that gives us line rate going as fast as possible for that transfer with very low CPU utilization. The short story is, these NICs are about the same cost as a 10 gig NIC. When you have a 10 gig NIC with RDMA, it's about the same thing. You just have to be careful which NIC you buy to make sure that they have the ability, right? And it also gave us access to these very high speed NICs, like 40 gig NICs or 56 gig NICs. And this was extremely successful in terms of achieving the goal. Now I can put this side by side with Fiber Channel, and it is at least as good as Fiber Channel and many times faster with as much as low latency as Fiber Channel. So that addressed that limitation that we used to have if you're really concerned about performance. Now, this is excellent for large I/O. We did have a limitation in small I/O. When you're trying to do 8K I/Os with RDMA, we actually left some performance at the table. For 10 gigabit NICs, we had no problem in 2012. But if you're using these 40 or 56 gig NICs, we weren't actually doing as well as we could. So in 2012, we improved that feature that I just described to be even faster. So now, for a single port of a single NIC, we used to deliver about 300,000 IOPS. We are now delivering about 450,000 IOPS. Most people I talk to are happy with 100,000, right? Most SANs that I talk to, the folks, deliver 100, 200. It's a very good performance. If you're talking about reaching 1 million IOPS remotely, that is huge. That is at par with high-end SANs. And that's where we are with this new capabilities. I'm going to do a demo of this. In fact, let's go ahead and do it right now. Okay, so the first thing I want to show you is how this thing works and how the new automatic balancing works in this release. So here I have a cluster that has 2 nodes, A1 and A2. And I also have multiple volumes. So if you see here, I have my witness in the middle, and I have 6 CSVs. Now, one thing that you'll notice is that I have 3 on node A1 and 3 on node A2. That was not a coincidence, and I didn't move them there. This is the behavior of CSV in 2012 R2. It will automatically spread the load across the nodes. Okay? Now, more important, if I go ahead here and I start a little workload, what you see is I'm running this workload on this machine, and I have on the other side Perfo monitoring the nodes. And you see that a single machine a single client is hitting the 6 different volumes, okay? And because 3 are in one node and 3 are in the other node, you see that I'm actually, from a single client, hitting the 2 nodes at the same time, okay? This is new in R2. I could not have done that in 2012. In 2012, a client would have chosen one of the 2, and then if the data is on the other node, we will do redirection in the back between the nodes to get the data and transfer from that single node. So this is better scalability in 2012 R2. Now, one of the things, if you saw the talk yesterday I did a demo similar to this. And one of the things that we can do is we can actually come here. Oh, I have a pending removal. Sorry. So we can actually come in here and manage this file server entirely from Virtual Machine Manager. So Virtual Machine Manager is the tool that you hopefully are using already for your VM creation, for your Hyper-V host provisioning and all that. And in R2, it is actually now able of doing also file server management. So you can, in here, if you go to your fabric, if you have a create, you actually now have a way from VMM to create a file server cluster. So this is a new ability in VMM in 2012 R2. The other thing that you might have noticed here is that in this environment, I'm running VMM 2012 R2 with Windows Server 2012 R2. In the past, if you remember, VMM would come a little later after the OS. Now, for the first time, we are in sync. And we are on schedule to deliver both the new capabilities in the OS and the management abilities for those capabilities simultaneously. I was never able before in the 2012 timeframe to do a demo at preview time already using VMM. So let me go back here and do what I meant to do, which is to add a node to the cluster. So I'm going to go ahead and add a node to my cluster. So I have two nodes. I'm going to go and say, this is going to be A3.test. So I'm going to go ahead and say, I want to add that node to the cluster. And I'm going to say, OK. And I'm going to go here to my jobs. And what VMM is doing, it is actually doing the steps to install the failover cluster feature, add the file server role, add the node to the cluster, and bring that new node into my two-node cluster. So my two-node cluster will become a three-node file server cluster. And keep in mind, all that while, my workload is running. Okay? So I can do this with the workload actively running. And it will take a while for it to go and do that. So I'm going to go ahead and switch to another demo. And I'll come back to that a little later. So I have another machine here. And this is my high-performance demo. Right? So I have two machines, very simple. One machine is a file server. The other machine is a client. Between these machines, I have high-speed networks, 56 gig InfiniBand high-speed networks. It's one of the types of the RDMA cards that I can use. Now, I only wanted to do this, in a mix of multi-channel and SMB direct. So instead of using only one, I'm using 3 of those cards. So 3 times 56. On the storage side, to try to keep up with that, I have 6 SAS connections to 48 SSDs. Okay? So let's see what this thing can do. So first workload is 8K. Let me switch to this. So what I'm doing is, on the client side, I'm creating 16 SQL Server simulations, hitting the different share. I have a single pool with all the 48 SSDs with a mirrored space on top of that, and then I create the file share on top of that, and then I have my workload hitting it. 16 different files, all doing SQL I/O. This is how many I/Os I can do in this system. So about 600,000 8K I/Os per second. You see here? These are 8K IOs, right? And 592, so almost 600,000 IOs per second. Now, do you know what this number is? It's the average time per request. So this is what we call latency. So what's the latency? Well, it's actually not zero because it can't be zero, but it's less than 1 millisecond. So it's below what I can measure, right? I think that it's about 200 microseconds in this case. So I have very fast NICs that can do RDMA combined with SSDs. So that's how low we can go. And if you pay attention, I mean, this is really a very impressive capability. Now, let me go ahead and do something else. So in this case, when I'm doing the 600,000 8K IOs per second, the reason I can't go any faster is my disk subsystem has limitations, right? So I'm trying now to do something else, which is I'm using cache on the file server side. So still the client, over the network interface, down to the other side, using caching. So instead of going to the disk, I'm actually going to memory on the file server side. And the notion here is I just want to talk to you about the networking stack capability that we have if you have good enough storage subsystem on the other side. So we are getting near 1 million 8K IOs per second. Okay? And this is remote. So there was I work with a guy called Klaus, and he was talking to me about something that he heard from a client saying, okay, guys, if you're doing 100,000 IOPS, that's okay. I can go for that. It's high-end workload. This guy's like a large enterprise. And he then said, you know, if you get to 200-300, that's fine. If you pass 750,000, then you're in the big leagues. And that's what we are delivering in R2. Right? We are brushing on 1 million IOPS. In fact, before I have another demo that I'm going to do with live migration that's using some cycles on this machine. Before that, I could actually go past 1.1 million IOPS per second. This is entirely, if you look at the number up there, I'm using almost all of my CPU to be able to do this. Keep in mind, 8K IOs. So a lot of these million IOPS demos that you see out there are 512-byte IOs. This is 8K, which is a real number. Another thing, this is going to a mirrored space with a formatted volume with NTFS on top. This is exercising our full stack. A lot of million IOs, when you go ask for it, oh no, we're doing raw IOs to disk. There's no file system here. Oh, so how do you use that? Oh, to use that, you have to format. It gets a little slower. This is not faking any of it. This is exercising the full stack to a formatted NTFS volume, okay, underneath this. Now, I wanted to do one more demo on the same, another type of workload, which is comparing what we had in 2012 with what we have in 2012 R2. So I did a demo at the Microsoft Management Summit a little while ago, which I had the very same hardware that I have here. And I was doing 32K IOs, okay? Back then, with 32K IOs, I was doing about 334,000 IOs per second. So I have that recorded from a previous event on this very same hardware. So what I did then was I just loaded the new OS with the new version, right, on both sides. And I'm going to redo that demo here. Let's see where we get. So let it spin. Come on, you can do better than that. There it goes. It's 16 processes, so it kind of has to kick in all this stuff. So 500. So let me describe what's happening here. First of all, this is again going to real storage. So this, I'm reading 32K chunks out of a single pool with mirrored spaces. Okay? 32, not 8, 32. I'm doing 500,000 32K IOs per second. Okay? Now, just look at the bandwidth on this thing. That's 16.5 gigabytes per second. Okay? How much can you get out of a 10 gig NIC? 1.1 gigabyte a second. So what is this? This is about 15 times more than 10 gig. Yeah, say again? It is 3 times 56 gigabit. So this is 150 gigabits per second that I'm doing. One machine talking to another machine. This is a few DVDs per second. Okay? It is. It is what it is. Now, this is so nice that the guys on the Hyper-V team looked at this and, you know what I could do with that? I could live migrate real fast, right? So in R2, they actually deliver that solution. And that's the other demo that I wanted to show you. So let me switch gears here. So I'm stepping out of the Hyper-V over SMB scenario for storage, and we're thinking about migration. So this SMB direct thing in multi-channel is so interesting that the Hyper-V guy said, you know what, I would love if you could give me that ability so that I could migrate with fault tolerance with remote direct memory access. So let's see what we can do there. And I'm going to compare the 3 types of migration. So I'm using very capable networking here, right? So this is a migration of a VM. This VM is actually a 48 gigabyte VM. Okay? So there's a 48 gigabyte VM. This is the traditional migration. So the blue line is the bandwidth that I'm using. So I used about 2.2 gigabytes per second, which is very good. But still, this is taking, what, 29 seconds to migrate. Not a bad solution at all. I'm going to migrate back, and I want to show you what is the bottleneck on that environment. So look at my CPU here. So when I'm migrating, because I'm using a single TCP connection, I actually affinitize with one of the cores of the machine. So if you look here, can you see this guy? This guy is my bottleneck. Because I have a single TCP connection, right? That single TCP connection makes one of my cores very, very busy. And then I can't go any faster because I have to chunk the data, send to the other side, reassemble, and that's done through one of the cores. One of the things that multi-channel addresses is that we in SMB are now able to spread that across multiple cores because we use multiple connections. Okay, but this is the traditional migration, so let's not think too much about that. The lines at the bottom there are CPU utilization. So in one side, in the source and the destination. So that is about a little over 10% CPU to use this traditional method. Now, let's look at compression now. So Hyper-V delivered a new method of migration where instead of just getting the data and sending to the other side, I actually compress the data and then send. Look at the blue line. That means we're sending a lot less data. Why is that? Because we're compressing that data before we send over. What are we trading that for? We're trading for CPU. Look at the spikes in CPU and source and destination, okay? Now, granted, Hyper-V did a lot of work. It's only using that much CPU because the CPU is available. So Hyper-V Live Migration will do the work to tame the CPU utilization so that it doesn't take CPU away from the VMs. And if you don't have much CPU available, it will actually look a lot more like the first migration. And then I'm migrating back just to see. Now let's see what RDMA can do for us. I'm going to now, so this took 22 seconds, so faster because I had the CPU to do it, right? Now let's do this with RDMA. So with RDMA, I will enable that, and instead of transferring this data, chunking and sending those small chunks, I'm going to actually transfer large 1 megs of data, 1 meg chunks, and the NICs will do most of the work, right? And because I'm using SMB, I'm actually going to use my 3 NICs at once. Look at that. We literally went off the chart. So this chart goes up to 10. As I showed you before, this guy can go higher than 10, right? So this transfer took only 13 seconds. But effectively, if you look at the blue line, the data transfer itself took just 3 or 4 seconds. That is 48 gigabytes of VM memory. Okay? Now, of course, Hyper-V has to think a little bit before it starts and has to think a little bit after to kind of calculate what I'm moving there. Can you allocate? Can you do it? So overall, it takes 13 seconds. And then I'm migrating back. There you go again. I want to show you the number. We actually went into scientific notation over there because the number is too big, but that's 18.5 gigabytes a second. Memory to memory. Nothing's holding us there. Okay? I have an interesting data point, which I think it's even more impressive. The Hyper-V guys tried to do this with 4 NICs. It didn't go any faster. You want to take a guess why? Well, it turns out that DDR3 memory has a limit. Right? So it was actually faster than the speed of the RAM itself. How about that? I really did chuckle at that. Now going back to our other demo, right? We finished adding that node to the cluster. And now you can see that not only now I have 3 nodes in my cluster, but the disks in my cluster, if you look here, I'll sort by owner node. You see that I have some on node A1, some on node A2, some on node A3, right? And now my single client is hitting all 3 nodes of the cluster. And I actually never stopped the workload. It was the same workload hitting all 6 shares. Okay? Cool. So a little bit of my demo summary. So we went from 2 nodes to 3 nodes. The numbers in terms of performance, right? 8K reads from disk, 8K reads from cache, and 32K reads from disk. Okay, so I went a little over ahead of myself, and I talked about the live migration over SMB already. But the main notion here is Hyper-V is now integrated with this, and you have a new option to do live migration where you can actually do faster migration using multiple NICs, which give you all the benefits that we talk about in SMB. And there's the option over there to do SMB. Okay? One of the things that with all these different types of traffic using SMB, you have cluster traffic using SMB, Hyper-V over SMB, live migration over SMB. We delivered a new capability called bandwidth limits, also called bandwidth management. So we can now say, okay, for live migration, I don't want to use much more than this much bandwidth. We can control that so that you can have access of VMs going to the storage and migration at the same time without one interfering with the other. And this you use on top of the storage cost that Hyper-V has delivered in R2 as well. So you have live migration traffic has a limit, then you have the limit for the other types of traffic, and then in that you can then do per VHD limits as well with Hyper-V, okay? And I already did that demo. And in that demo, that's the setup in case you were wondering, right? So we have 2 hosts, each with 3 NICs, and the storage down there in spaces in a mirrored space. So that's kind of just the shape of the 3 types of migration. Okay? We can also do encryption. That was introduced in 2012. The notion here is if you care for encryption, you can now do it by simply checking a box. And SMB itself has a way to, before we can connect, we have to authenticate. And we have a secret that we share between the machines. And we use that to derive a key. So that means encryption without the need for certificates, without the need for PKI. Okay? We do use the AES encryption that can be accelerated by the CPU. So the modern CPUs have AES-NI that can help with that encryption, right? So this is also available through SMB. Solution for backup. So we have VSS for SMB file shares. If you know how backups work in Windows, we have VSS as an infrastructure for doing what we call volume shadow copies on block storage. In order to, in the spirit of keeping parity with block storage, we have a way to do the same kind of backup with file storage as well. And in R2, we have a new capability to, again, in that spirit that multiple things are using SMB at the same time, we now have a special SMB channel between the nodes of a cluster. So we have what we call a CSV instance for SMB. So when one node of the cluster talks to the other node, like a back channel conversation, those nodes use a dedicated instance of SMB. And this is something that is an architectural change we made, so make sure that if we have a larger cluster, and we have a lot of back-channel communication, that communication doesn't interfere with the SMB traffic between the Hyper-V hosts and the file server nodes. So again, doing work on our architecture to make sure we scale well and we can handle those very high load configurations. Oh, one thing that I love about that, we also did a lot of work in diagnosability. So typical situation is you're using this stuff, something doesn't work, and you find yourself trying to figure out what went wrong, right? And in SMB, we did a lot of work in this release to improve our events. So this is a sample event there. This is an access denied error, okay? So in order to use Hyper-V over SMB, I'll talk about this, you have to grant access to the nodes of the cluster. If you don't, when you try to access, you get an access denied error. Now, in the past, our event was like, access denied, go figure it out, right? In this release, it now says, okay, so this client using this credential came into this share, which maps to this folder, and got an access denied. And here's what the detail is. And take a look here, some guidance for you on how you could go ahead and figure that out. So we did a lot of this work, especially, for instance, say, for instance, you're trying to access a share, and you get a path not found error. That could be the host name is wrong. That could be the share name is wrong, so it could be a DNS issue, it could be a share issue. So we're trying to now, in the event log, put a lot more information so that you can more easily troubleshoot this. So again, in R2, our effort to round up the scenario, attention to detail to make it work better, diagnosability is a big piece of it. I mentioned that during my demo. VMM integration with the scale-out file server. So I would highly recommend that you take a look at Hector's session. Hector is a PM in the VMM team, and they are doing amazing things, for instance, for, you remember those permissions that I talked about that you have to give permission? They automatically do that in VMM. For instance, they are now doing bare metal deployment of file servers. They are now automatically creating a share from a pool, so they can create the space, format, put the share on it, do all the work directly from VMM. And as I showed you, I can add node, remove node from the cluster using VMM instead of failover cluster manager. So enabling VMM to manage. So VMM was actually always very good at handling the Hyper-V cluster, the compute layer. Now they're getting really good at managing the scale-out file server and the storage spaces behind it, down to the creation of pools using VMM. So you get the raw disks, put in a pool using VMM, and then from the pool create the volume and the share using VMM itself. So this is new in VMM 2012 R2. Let's talk a little bit about configurations. Three main types, so standalone file server, 2-node file server with SAS storage in the back, and fiber channel in the back with file server up front. So obviously, what we're encouraging you to do is option B, right? But you can also do standalone file server. The only problem with having a standalone file server is if that file server breaks, that's downtime for you, right? So we don't recommend that. It does work. And if you already invested in fiber channel, one thing you can do is you can front end that with a file server, so you don't have to wire fiber channel to all your Hyper-V nodes, right? So a lot of folks have been using that as an option as well. Network, you can use all 1 gig. RDMA is absolutely not required. I get that a lot because I like to talk about RDMA all the time. People say, oh, so RDMA is a requirement, right? No, actually it's not. We have a lot of folks that use traditional 1 gig NICs, 2, 3, 4 1 gig NICs. You can also use traditional 10 gig, but you also have the option to use RDMA. And option D is the mythical converged network, right? So you have all your compute nodes and your storage all talking to a set of high-speed switches, and you're using converged Ethernet networking, which, by all means, let's go do that. How do you configure this? Very straightforward. Create the folder, create the share with the proper access, and we now added in R2 a new commandlet called set SMB path echo that essentially takes the echo that you have on the share and copies to the folder. So you know that in SMB we have the share permissions and the folder permissions. People sometimes forget that there are 2 sets, so we made it extra simple. When you create the share, you set the permissions. So this is what you want to do. The admin has permission, the nodes of the cluster have permission, and the cluster object itself has permission. And then by simply doing this, you say, okay, get the share and apply the permission to the folder. That's a new commandlet there. From the GUI, you basically just use the UNC path where you would otherwise use a local path. That's as simple as that. Or you can use PowerShell. So when you create the VHD, you specify the path. When you create the VM, you specify the path. So just very straightforward way to configure this. One of the things that we are proud to do is to make this as simple and straightforward as possible, right? Jose, how do you configure multi-channel? You don't. Just configure the NICs. If there are multiple NICs, they will engage. How do I configure RDMA? You don't. If the NIC supports RDMA, it will happen, right? That's about it. How do you configure encryption? Well, that one you have to do it. On the creates of the SMB share, there's a dash encrypt data. True. That's it, right? That's one more option that you might want to do that. We also use Server Manager to create those as well. A few things. In order to do Hyper-V over SMB, you must use SMB version 3.0. Okay? Now in R2, we have 3.02, but I'm not even going to consider that. Just call it 3.0. So both 2012 and 2012 R2 are 3.0. You can also use third-party SMB implementations. NetApp is implemented it. EMC has implemented it. Samba 4 has implemented it. There are a few other guys that are implementing SMB 3. That's fine as long as they are version 3 of the protocol, okay? And they must implement continuous availability. It's very important. They all do, by the way. Not all of them do SMB, I guess none of them yet do SMB direct. Multi-channel is also sometimes not implemented, but the basics is continuous availability. You must have that because that's important for our high availability story. You must use Active Directory. Why? Because our permissions are using computer accounts. So if you don't have Active Directory, you don't have computer accounts. So that is a requirement. And you can use Virtual Machine Manager 2012 SP1, but if you have the opportunity, VMM 2012 R2 is really, really improved. Okay? There are a few other details there that I'm not going to go. I have on my blog a lot of different tips that you can go do it, a lot of questions. So for instance, can I use SMB without RDMA? Answer is yes. I only have 2 NICs. Should I team them or not? So have a lot of interesting guidance that have been accumulating over time. So I would encourage you to go and review that. This deck will be available to you. Actually, it is already available to you on the website. You can just click on those and they will take you to those articles. Also, very important, as we are working through this, we have made a few fixes available. There's some related to VSS, some related to cluster resiliency. So I would highly recommend that you look at those KB articles, and especially the last one has a hot fix. If you're deploying 2012, by all means, do take a look at that. If you're using 2012 R2, those are all included. Talk a little bit about performance. A lot of folks ask me, Jose, does this thing perform? And I hope my demo has shown that you can make actually a configuration that performs really well. But performance is a factor of your configuration. And there are things that you have to worry about. You have to really be concerned. If you have, for instance, all SSDs in the back, but you connect to it through 1 gigabit NICs, if you have a 1 gigabit NIC, that will give you exactly 110 megabytes a second. No more than that. That's physics, right? So you have to have a balanced configuration. You have to have, in the same fashion, right? If you put all 56 gig RDMA, and in the back you put 4 terabytes, 7.2 RPM disks, it's going to be bad. Especially if you're doing random I/O, it's not going to be good. So you actually have to have a balanced configuration. So these are the main components, right? So you have the JBODs in the back. The connection between the JBODs and the file server, typical configuration is with SAS. So SAS has some limits. The most common type of SAS is 6 gig SAS. And the SAS HBAs usually have 4 lanes of connectivity. That gives you about 2.2 gigabytes a second on that path. With multiple paths, you can go faster. So the configuration I was using 6 SAS connections between the systems, and that is a requirement because I'm achieving very high throughput, right? And each one of those SAS HBAs has multiple paths. So you have to pay attention to that. Then between the file server and the Hyper-V cluster, you have to have also good connectivity. So in this example, I'm using 2 RDMA NICs connected to 2 different switches. Why 2? For fault tolerance. You always have to remember your fault tolerance. So in order to have fault tolerance on the file server cluster, you have to have at least 2 nodes. And in order to have fault tolerance in the networking side, you have to have 2 NICs, preferable with 2 switches. So you can actually fail a switch as well as the NIC, right? And it's no coincidence that I'm using 3 JBODs, because that's how you can get JBOD fault tolerance with storage spaces, right? So there is an option in storage spaces where you can say, I want my mirroring to be enclosure aware, meaning that one copy of the data goes into one JBOD, the other copy of the data goes into another JBOD. You can lose an entire JBOD and the data is still available, right? Now, you do have to have 3, okay, so that you have enough votes in the surviving configuration so you can figure out what happened. If you have only 2 and you split, you don't want them both thinking that they're able to keep going separate, right? You want to avoid those split brain situations. And of course, you have your stack that goes to SMB separate from your stack that goes to the client. So 2 separate networking stacks there. Few things that you have to consider, right? Everything there is a variable. How many SAS ports? How many disks? What the type of disk? Now with R2, so the highlight in black are the things that changed in R2. So disk type is now important. You can now mix hard disk drives and SSDs using tiering, right? So how do you do that? You have to be careful about that. CSV cache configuration. So the file server, when using CSV, has a way to use in-memory caching, so RAM caching. It changed between 2012 and R2. In 2012, you could use up to 20% of your RAM. We're very conservative. In 2012 R2, you can use up to 80% of your RAM for caching. Okay, so some changes there. And of course, you have to watch the speed of the NICs, how many NICs, how much RAM. So there's a number of things, and I always like to go through a little exercise. So let's think about it. I have 500 VDI VMs. Each VM needs 2 gigs of RAM and 1 virtual processor. Now, for storage, I need 50 gigabytes of space per VM, and I have decided that I need 30 IOPS per VM. And you can ask all kinds of questions there, like, oh, Jose, I think 2 gig is too much. I think 30 IOPS is too little. My VMs are all 40 gig, not 50 gig. Just adjust for your workload. So in my building blocks, I'm using all hard disk drives, 900 gig hard disks at 10K RPM. And my disks can give me about 140 IOPS. So I have 2 types of JBOD that I can work with. I have a 24 or 60 disk JBODs, and my Hyper-V hosts have 16 cores and 128 gigs of RAM. And you might again say, oh, my Hyper-V host has 256 gigs of RAM. Just adjust accordingly, right? So first of all, in terms of IOPS, so if you need 30 IOPS per VM and you have 500 VMs, and each of your disks can give you 140 IOPS, based on IOPS alone, you need 107 disks for this configuration, okay? So it's 30 IOPS times 500 VMs divided by 140 IOPS per disk. Now, if you look at capacity, I have 50 gigs times 2, because it's mirrored, times 500, the number of VMs, divided by 900, which is the number of gigabytes per disk. And that would give me about 56 disks. Okay? Again, a lot of questions say, oh, my 900 disk doesn't give me 900 capacity. It actually 850 something. Adjust, okay? So from an IOPS standpoint, I need 107 disks. From a capacity standpoint, I need 56 disks. So how many will I use? Obviously 120. Why? Because I'm using 60 disk JBODs, so that's a nice 2 JBOD configuration, right? And I'm giving me some spare capacity so that I can grow a little bit or take a little bit of more workload than I initially planned. In terms of hosts, I have 2 gigabytes per VM divided by 128, so it's 50 VMs per host, give it or take, with some spare, because the host needs room to breathe, right? And then 50 VMs, 1 virtual proc divided by 16 cores, that's a 3-to-1 ratio. There's actually no limit there. It's more of a, the limit there is you start putting more until someone complains that it's slow, then you pull back a bit, right? But that is usually not a bad thing. So that's about 10 hosts. I'll use 11 so that I have a little spare so I can take 1 for maintenance. Maybe 12 would be better, right? On the networking side, I have 50 VMs, 30 IOPS, 64K. That is a total of 937 megabytes per second, okay? Now, that I can get out of a single 10 gig NIC, because a single 10 gig NIC is 1.1 gigabytes, or 1,100 megabytes a second. But I always want 2 for fault tolerance, so I have enough room to breathe there, even when there's failures, right? And then single SAS adapter with 4 lanes will give me more than enough than what I need. So this is a very balanced system. On the file server side, I need to deliver 12,000 IOPS. That's like a yawn, right, from a file server side. It's nothing. And we can handle that with a single file server. Obviously, you never want to deploy just one, so 2 for fault tolerance. And then 64 gigs is a good size for your cache. Now, I have to update that. It's no longer up to 20% for cache. It's up to 80 in R2. And a little homework for you. In this case, it's clear that I have a set of requirements for IOPS and a set of requirements for capacity, and they are not rhyming, right? So what I could do here, I could use tiering and use fewer disks, but have a few hard disk drives and a few SSDs, and that's a homework for you, okay? Figure out how to do that with tiering. So that's the resulting solution over there. So very simple way to do it. So this is the thinking about performance is you have to design those things in a way that works for you. If that's too much for you, right? Some folks say, Jose, stop. I can't take this whole thing about speed of fiber channel interfaces and how much is the slot capable of delivering and what is 56 gig InfiniBand and 10 gig. What you can do is you can buy these things pre-configured, right? So a number of our partners are delivering what we call a cluster in a box configuration, right? And what you get is a 2-node cluster with some disks all pre-configured running Windows Server out of the box, right? So that is one option. There's actually a session tomorrow by John Lovell where he's going to describe some of the solutions that are out there in the market, right? And I would highly encourage you to take a look. Now, I put this maximum theoretical numbers here just so you understand. So, for instance, the DDR memory limit there, see? 8.3 gigabytes a second. That's the theoretical single direction. So if you're doing reads and writes, it actually doubles. So just some food for thought there. Now, a lot of folks come to me and say, Jose, okay, so that is the theory. Can you show me a few things that people did, right? And I have 3 sample configurations here that hopefully you'll be able to take a look and understand what people are doing out there. One of them is actually very close to you. If you go over there to where's the virtual labs? 8, right? It's across the... So virtual labs are actually using this. And Corey Hines, I'm not sure if you know him, he did one of the pre-conference seminars on Monday. And he's happily using Hyper-V over SMB all day long. Actually, he grabbed me on Tuesday night and said, hey, look. This is the number of connections. He had a computer over wireless connected to the thing, showing me the number of different connections that he was getting out of these servers. So he's deployed on that. He already had some fiber channel arrays. So what he did, he basically front-ended a set of arrays that he had with a few file server clusters. And he has this whole notion of gold, silver, platinum storage. So he has different types. And he wires that all up to his many Hyper-V hosts over a converged network with 10 gigabit switches, okay? So he's actually not using RDMA for this. He's using traditional 10 gig. But I love the fact that he tested this capacity up to 7,000 VMs in this environment, which is no easy feat, let's admit. And he has been doing this for some time. So I gave you some data points there so you can see how it's going. Another one, there's a crazy group at Microsoft that does a lot of infrastructure. So they're deploying a 28-node solution with 10 gig switches going to a 4-node file server cluster going to an MEMC vMax. So that's yet another kind of solution. This is very high-end because their VMs are really huge. So they're using 32 gig VMs, right? and they're doing a lot of very sophisticated workloads, like high-end databases and all that. And they're deploying this using, again, our Hyper-V over SMB solution. And I'm not sure if you heard the story about NTTX. That's one of our case studies that we have published for Windows Server 2012. And they're experimenting with R2 already. So this is like several different clusters that they have. On one site, they use 1 gigabit networking going to some JBODs, all using spaces. On another site, they're doing 10 gig switches and another set of file server clusters. And I got a lot of questions about this. So like, why don't they do one big file server for everything, right? Why do they have that stuff with 1 gig networking? And well, this is a solution that he built himself, and he did some work on it. Some of it is the limitation of how SaaS connection works. Some of it is how it grew over time. So there's a lot of different things. This is more real world, right? This is not like a sample thing. This is how they figure out to do it. And you see, they don't have all same cluster. They're multiple clusters because they got configured over time. That's one of the things about Hyper-V over SMB. I don't have to actually wire the storage to a specific cluster. I can actually have lots of different file servers connected to lots of different clusters out there, and it's very flexible to create those configurations. That's one of the main advantages. Lots of these live migration solutions that we talk about here get better when you do this with Hyper-V over SMB. So in closing, right, I wanted to give you a solution, first of all, that can be used day one with 2012 if you're ready to go. And if you're starting to investigate, I think it might be interesting to take a look at the preview if you're not deployed yet, if you have the opportunity. That would be a good thing to start thinking. The preview, you know, we're going to release that by the end of the year, right? So if your project timing allows it, maybe you want to do it with 2012 R2. But if you're ready to go right now, you can easily go to 2012 the way it is. And we are seeing more and more folks understanding that you get more flexibility. It's not only about the cost of buying the gear, it's also the cost of running the service, right? So it's simplified, it's convenient to do it. And I hope our brushing on performance, a little bit on configurations will help you understand what we can do here. I welcome you to come over to the XD Experts Night tonight. We're going to be there. And I also have a talk on upgrade from 2012 to 2012 R2 later today at 5. And tomorrow I also have a talk on shared VHDX for guest clustering, which is another topic that's interesting. So I welcome you to do that. With that, if you have questions, I think we have a few seconds left. Maybe? Yes. Does the scale-out file server cluster support ODX? Actually, ODX is a technology that lives on the storage side. So if you are using an array in the back that uses ODX, we will flow the ODX request through the file server, right? So the demo that Hector sometimes does and all the storage guys do, they usually do it over SMB as well. So yes, if the array in the back supports ODX, you can flow that through the scale-out file server, okay? Okay, so the question is about designing a fabric, a converged fabric, where you have RDMA and other workloads. So one of the things you have to keep in mind is that when you're using RDMA and teaming together, you have to have a set of NICs that you use for RDMA and a set of NICs that you use for teaming. Because if you team a NIC, it becomes a virtual team NIC, and you can no longer do RDMA on it. So RDMA needs visibility to the hardware to make that happen. So I would strongly encourage you to go back to that diagram and look at how we design it, right? So a NIC for RDMA and a NIC for teaming, or 2 NICs for RDMA, 2 NICs for teaming. And if you want to do true conversions, you can actually mix the two. You won't be using RDMA in that case because you can't wire RDMA to the vSwitch, but you can actually do team NICs going to the switch. Out of the virtual switch, you take a couple of NICs for the host to do SMB, and then you do the others to the VMs, and you can do it that way. One of the articles I have there is how to do teaming with only 2 NICs and also use SMB at the same time. So I would encourage you to take a look at one of those there. Any other questions? Yes? So is there any difference between Ethernet, 10 gig, and InfiniBand? Actually, InfiniBand typically is only 32 and 56. So I guess the question could be framed as, what's the difference between 40 gig Ethernet and 56 gig InfiniBand? Those are different fabrics. They work a little different. A lot of folks have preference for Ethernet because they want to have this converged environment. And if you're using InfiniBand, you have to have a different kind of switch. The InfiniBand switch can have an Ethernet uplink as well, right? But some folks don't want to go there or have concerns. In general, I have been very happy. So the demo I did here was actually InfiniBand, the NICs I was using. We use 10 gig. We use 40 gig. It's a personal preference in terms of your networking architecture. And we also have 2 types of Ethernet that we can use. That's Rocky and iWarp. So those are different technologies as well. I have a little deep dive on those on previous talks, and we can elaborate more. But we make a point of supporting all these different types of networking technologies. And from your perspective, it should work the same. There's a NIC. You set an IP address, and it works for TCP/IP. And if RDMA is available, it will just leverage RDMA. So that's the main thing. I've seen a lot of folks doing 10 gig right now because that's what they're comfortable with. But there's a wave of faster NICs like 40 gig and even 100 gig on the horizon. So we want to make sure we're ready for those. Okay? I think I'm out of time. Thank you, everyone. And let's start playing with these technologies, right? Take it to the lab, play with it, let us know what you feel. Thank you.